What's up guys, and welcome to the first video in a new series where I'll be analyzing circuits and solving them step by step. For our first example problem, we have the following circuit with a 20-volt battery and 9 resistors. Our goal is to find the total equivalent resistance of the circuit and also the current through and the voltage across resistor R8. Let's start by labeling all the positions in the circuit where it would be helpful to know the voltage values. If we can find the voltage at each of the labeled points, we can calculate the voltage across each resistor. For example, the voltage across resistor 1 is VA minus VB, and then using Ohm's law, we can calculate the current. Now let's calculate the total resistance of the circuit. Let's start with the resistors furthest away from the battery and work our way inwards. Now resistors R7, R8 and R9 are in series with each other because they are connected end to end, and the same current that flows through R7 will flow through R8 and R9. Let's replace the series combination with a single equivalent resistor. For simplicity, I'll redraw the circuit, substituting the series combination with its equivalent resistance. Now moving inward, we can see that we now have a parallel combination. Let's calculate its equivalent resistance and simplify our circuit further. Here's our redrawn circuit with the parallel combination replaced by its equivalent resistance. Continuing this process, we see that R4, R6 and our second equivalent resistor are in series with each other. Let's calculate the series equivalent and redraw the circuit once more. Following the same pattern, we'll find the equivalent resistance of this parallel combination and simplify our circuit again. We've now reduced our entire circuit to just 3 resistors in series. This makes it straightforward to calculate the total resistance and using Ohm's law to determine the current supplied by the battery. Let's work backwards to calculate the currents and voltages across each resistor. We'll start by calculating the voltage at each point in this circuit. We know that the voltage at point H is 0 volts because the voltage at the negative terminal of the battery is always 0 volts. The voltage at A is 20 volts because the battery supplies 20 volts to the circuit. But what about the voltage at point B? The voltage at point B is the voltage at A minus the voltage drop across resistor R1. Since RT represents the series combination of R1, R equivalent 4 and R3, the current flowing through RT is identical to the current flowing through each of these series connected components. Now that we've determined the current flowing through R1, we can calculate the voltage at point B. The voltage at point G is equal to the voltage at point B minus the voltage drop across resistor R equivalent 4. Let's take another step backwards by breaking up R equivalent 4 into its components. Since R equivalent 4 represents the parallel combination of R2 and R equivalent 3, the voltage across R equivalent 4 will be the same as the voltage across R2 and R equivalent 3. Now that we know the voltage across R equivalent 3, we can use Ohm's law to calculate the current. We also know that the resistor R equivalent 3 and this series combination are equivalent. Therefore, the same current flowing through R equivalent 3 will flow through this series combination. Next, let's calculate the voltage at point C and point F and the voltage across resistor R equivalent 2. Remember that R equivalent 2 represents the parallel combination of resistor R5 and R equivalent 1. Therefore, the voltage across resistor R equivalent 2 is the same as the voltage across R5 and R equivalent 1. Knowing the voltage across our first equivalent resistor, we can calculate the current through it. Because R equivalent 1 represents the series combination of R7, R8 and R9, the same current flowing through R equivalent 1 will flow through the series combination. Finally, we can calculate the voltage across resistor R8. We have completely solved the circuit by reducing it to a single resistor and then building it back up. If this step-by-step approach was helpful, please like the video and share your thoughts in the comments.